Graph, usually a graph, but any function can have an asymptote, right? Where it can't exist. In other words, where I get undefined, right? Where I'm undefined. So, okay, so the line x equals a is a vertical asymptote, so vertical going up and down, of the graph where, so at a vertical asymptote, we have two choices. From the left, we can go up to positive infinity or down to negative infinity. To the right, we can go, same thing, up to positive infinity, down to negative. So if you remember, we can get a, so when does the limit not exist? So when do we have a limit that does not exist? Has to be from two sides, right? From two sides, they don't meet at the same point, right? So today, we're only going to be looking at either the left side or the right side. So those are one-sided limits. Those always have an answer. We can never have does not exist for one-sided limits, okay? The reason being, right, the definition of a limit that doesn't exist is from both sides they don't meet, right? Well, if it only has one side, it has to be approaching something, right? That's what we're going to talk about today. Okay, so one-sided limits we're going to focus on. Okay, so note, this occurs whenever there is a value that gives you 0 in the denominator, right? So if I was putting numbers in my calculator, when will my calculator say undefined or error? When I'm trying to divide by 0, right? Anytime I try to divide by 0, it doesn't matter what's on top. Anytime I try to divide by 0, your calculator is either going to say undefined or it'll just say error, right? That's when an asymptote or a hole exists, okay? Or a hole exists. So this occurs whenever there's a value of x that gives you 0 in the denominator, but not the numerator. So we don't really care what number we get up here. I could care less what number it is up there. All it really focuses on is the bottom, right? Okay? So if the value of x gives you 0 in both the denominator and numerator, there's a hole. So if it's 0 over 0, that means there's a hole there. Okay? Okay, so let's look at 1a, or 1a, yeah. So we need to find vertical asymptotes. So anytime we need to find vertical asymptotes, always focus on the bottom. If there is no bottom, there's not going to be a vertical asymptote, right? So this one has a denominator. All right. Oops. Right here. We're going to focus on the denominator, right? Because it's where the denominator, denominator equals 0. 0. Okay? That's where you're going to have a vertical asymptote, right? If the numerator and denominator equals 0, that's a hole. Okay? So if I were to plug in a number and it gives me 0 over 0, we know there's a hole there. If it gives me something over, if it gives me, if the bottom makes a 0, that's where the vertical asymptote. Okay? Okay, so if we want to know where the green equals 0, set it equal to 0, right? Solve for x. So what's the first thing we're going to do when we solve for x? Some of you can do this in your head, but let's pretend you can't do it in your head. What's the first thing I would do? Add 4 to both sides, right? Add 4 to both sides. And then if you want to get x by itself, divide by 2. X equals 2. So what that tells me is if I plug in 2 to the bottom, I would get 0 on the bottom. So in your head, plug in 2 to the top. Would I also get 0 on the top? No. So that means it's not a hole. It means a vertical asymptote. Okay, so there's a vertical asymptote at x equals 2. So that means if you were to graph this guy, there would be a line. It kind of would look like the ones we saw. Let's see. See this line right here where it's x equals 5, like that? Those are vertical asymptotes. Okay. All right. All right, so let's do the next one. I don't know why I got smaller, but let me make it bigger. Okay, next one. Focus on the bottom, vertical asymptotes. Anytime you're trying to find holes or vertical asymptotes, start with the bottom and then go from there. Okay, so we're going to set that equal to 0. Okay, so we have x squared minus 4x plus 3 equals 0. So what do we got to do? So how do we solve for x on this one? This one's a trinomial, right? So we can't isolate x. So we do what we did before, a, b, c. So we know a is 1, b is -4, c is 3, right? We try to figure out what the two numbers are that multiply to be -4 and add to be 3. What are those two numbers? 3 negative. So be 4, right? Oh, yeah. Sorry. Yep. 3's on top. -4 is on the bottom. That makes more sense. So -3 and -1, right? So we got -3 and -1 with x, right? Divide by a. So what is a? 1. So it's not going to change anything. So you get x minus 3 and x minus 1. Let me go put those back over here. So now you set those both equal to 0. Both binomials. X minus 3 equals 0. X minus 1 equals 0. So you get x equals 3 and x equals 1. We get two answers. Okay, so are they both asymptotes? Are they both vertical asymptote? Is one of them a vertical asymptote, one of them a hole? Are they both holes? How do we know? What's the test to check to see if they're just plug them in, right? And if what do we get on top? So now if I were to plug in 3 on top, would I get 0? No, that's a vertical asymptote. So this guy right here is a vertical asymptote. If I were to plug in 1 on top, would I get 0 or would I get something else? 0, so this is a hole. So for the question, if I was answering this question, it would only be 3. I wouldn't put 1 because 1's a hole. Okay. All right, last one. I think on this page. Yeah, on this page, last one. Okay, so go for it. Go ahead and try that one on your own. Tell me what you get as a vertical asymptote. So you don't have to square it. We're solving it. Just undo it. So to get rid of the squared, how do we get rid of the squared? Square root, right? That's the opposite of squared. So I'm going to take the square root of both sides. So that would be x plus 1. Square root of 0 is just 0. Subtract 1 from both sides. I get -1. So is that going to be where a hole exists, or is that going to be where a vertical asymptote exists? Vertical asymptote. Yeah, why not a hole?
There's no x.
Yeah, can't plug anything on top. It's always going to be 1. Numerator will always be 1, right? So therefore, it's a vertical asymptote. Okay? So what that means is if I were to graph this, I don't know what it looks like, but I know at -1, there's going to be a dashed line which it can't touch. And we'll go more into that on the back. Okay? So it's going to be doing something on the left of the dashed blue line. It's going to be doing something on the right of the dashed blue line. But at the dashed blue line, it's not going to touch it. Can't touch it. Can come close, but it can't touch it. Okay? Okay, so taking that idea, 2A should look familiar. It was 1A, but they're asking us a different question, right? They're asking us a different question. They're not saying vertical asymptote anymore. They're saying, what's the limit as x approaches 2 only from the left. So only from the left. So we can't get DNE for this one. Okay? So one-sided, let's write that down. Let me write that down. One-sided limits will never equal, or will never be, I should say, will never be DNE. No, that says will be. Will never be. Never be DNE. Okay. All right. So this guy here, what do we know, since this is number 1, this was 1A, right? What do we know about it? Is there any background that we know about it? About the function. So about that part there. Is there anything we know about, what happened? That part there, the green part? It has a vertical asymptote, right? Has a vertical asymptote at x equals 2, right? X equals 2. Okay. So let me draw a little picture, kind of like I did for the last one, 1C. I'm going to draw a little sketch. That means +1, +2, +3, -1. So that means at +2, there's a vertical asymptote like that, right? I don't care what's happening on the right side. Why don't I care what's going to happen on the right side of the blue dash line?
We're only looking at the left side.
Because we're only looking at the left side, right? So I only care about the left side, what's happening on the left. Okay? Okay. So if I'm coming from the left, can I ever touch the dashed blue line? No. So what are the two options? If I'm coming from the left, what are the two options? Like, for example, if I'm coming like this, I can't go through it, right? I can't touch it in any way. So what are the two options if I'm coming at it? Yeah, to hug it going up or to hug it going down. So what are those two values going to approach if we do that? So let's say we hug it up. What y value is it going to approach? Positive infinity. And same thing with the opposite, right? Negative infinity. Okay, so that's going to be one of our two answers. Either they're going to be positive infinity or negative infinity. Nothing in between. Okay? So to do that, we have to see, as we're getting closer and closer, am I going up or am I going down? Where are the y values leading me? So what I'm going to do is I'm going to make a little table. I'm going to make a little x and y table. X, y table. Okay? I'm going to choose some points and go from left to right, because that's what negative means, right? Go from left to right. So I'm going to start with -1. Let me plug in -1 into the original. So if I plug in -1, so it would be -1 squared, right? -1, and then 2 times -1 minus 4. So So let's do some mental math. On top, what would I get? 0, right? I'd get 0 on top. What would I get on bottom? -6? Which is 0, right? So let me make that dot. So -1, I would get 0. So let me get closer. What's the next value? What's the next x value that's closer to the blue line? 0. Plug in 0. 0 squared minus 1 over 2 times 0 minus 4. So 0 squared is 0, minus 1 is -1. 2 times 0 is 0, minus 4 is -4. You get positive 1/4, right? So did it go up or did it go down? It went up barely, right? It went from -1, 0 to 0, 1/4. So it did go up just barely a little, not even a whole unit. So if we had a whole unit there, it would be like that. So what I'm going to do now is I'm going to plug in the next value that's closer. And if it continues going up, I know it's going towards positive infinity. But if it switches, then I have to check it a little bit further. Okay, so let's plug in 1. 1 squared minus 1 over 2 times 1 minus 4. So I get 0 over -2, right? Which is just 0. So it went down. Wait, let me double check my stuff here. Yeah, I do. Okay. So we're going to plug in 1 more to see where it goes. And that's going to be 1.5. This one is more mental math. It's not necessarily we need to come to an answer. We just need to know, is it going to be positive or is it going to be negative? Okay? So 1.5 squared minus 1, 2 times 1.5 minus 4. So oops, no. There you go. So again, I don't care what the actual number is of this answer. I just want to know if it's positive or negative. If it's positive, it's going up. If it's negative, it's going down. So on top, when I square 1.5 and I subtract 1, would I get a positive or negative number? Positive. What it is exactly, I don't care. But I just want to know if it's positive or negative. So on bottom, if I go, what's double 1.5? 3, right? Subtract 4? Negative number. So I would get a negative number. So that means this guy is going down. It's moving slowly, but it's moving down. So therefore, the limit as x approaches 2 from the left is negative infinity. Negative infinity, not positive infinity. Okay. All right. 2b looks like 1b. Right?
Jam in a printer?
Yeah.
They said that.
What is some background about 2b? We got a vertical asymptote. Where do we have a vertical asymptote at? X equals, no, it wasn't 0. What was it on the other side? What did we get? 3, right? And then there was a hole. Then we had a hole at 1, right? Right, that was our 2 points there. Okay. So again, we know there's a vertical asymptote, and look at what they're asking. They're asking for the limit as x approaches 3 from the right. That's where the vertical asymptote is. So again, I'm going to draw a little graph just to give me a visual. Kid, do you have to draw a graph to do that? No. But like I said, it helps me. Anytime you can make math visual, it always helps. Even for the best math students like you guys. Always helps, okay? So I know there's a hole at 1, but I could care less about that because they're not asking about 1. They're asking about 3, right? So that's where I'm going to focus all my attention on. 3. And it's only from the right side. So I'm going to go 4, 5. Okay. So I want to get closer and closer to the vertical asymptote and figure out, so I have 2 options. Is it going up to positive infinity or down to negative infinity, right? So pick 2 values. Always pick the 2 closest, easiest that you can. So I'm going to pick 5 and I'm going to pick 4. So 1 minus 5. And then 5 squared minus 4 times 5 plus 3. Okay, so do a little mental math. 1 minus 5 is negative 4. 5 squared is 25, minus 4 times 5 is 20, so that's 5, plus 3 is 8. So negative 4/8, which is negative 1/2. Okay. So 4 will tell us which way it goes. So is it going up or is it going to go down? So let's plug in 4 now. So I get 0 on top. And then I get, oh, no, not 0. I get negative 3. I don't know where I got 4 from. So it's negative 3 on top. Let's see, 16 minus 16 plus 3 is positive 3. Negative 1. So as we went from the left and got closer and closer to the asymptote, are we going up or down? Down.
Yeah.
So that means negative infinity. Okay? So do you need the graph to do this? No, but I find it's easier for me to do it. If you don't need the graph to do it, go for it. Just show me what your method is. So on a test or a quiz, do I need to see a graph? No. Bless you. Do I need to see a graph? No. But I want to see your method. How did you do it? How did you figure out that it was negative infinity or positive infinity? Okay, that's all I'm looking for is your method. Okay, all right, so now do C. Do 2C. All right, so we knew that there was a vertical asymptote at x equals negative 1. Okay, and they happen to be asking us about negative 1. So the reason I have to go through this whole process is because I can't plug in negative 1. I'm going to get 1 over 0. So it's coming from the left because it's negative, right? So I plug in values at negative 3. I find I get 1/4. At negative 2, I get positive 1, so I can tell it's going up. So let me put a little wrench in there. What if the limit wasn't negative 1 from the negative side? What if it was the same exact function and you had 2 from the positive side? How would you do this problem? Let's say this is a quiz problem or test problem. How would you do it? You don't have to do it, but just how would you do it? The fact that you guys haven't said anything means you're overthinking it. You guys are way up here. Right there. How would you do it? Not even that.
It's not even approaching the asymptote.
Exactly. It's not approaching the asymptote, right? So what would we do? Just plug in 2. Plug in 2. You get 1 over 9. Done. Move on to the next problem, right? That's where they fool you with that. Sometimes they'll do that. I've seen that on a quiz where they give you this problem and you're expecting this problem here. What's the only reason we had to do all of this? Because the limit was approaching an asymptote, right? If the limit isn't approaching, if the limit and the asymptote have nothing to do with each other, solve it like you would a regular. Solve it like you would a regular. Plug it in. You'll get an answer. Okay? Or you'll get 0 over 0, and then you guys can factor or do whatever you need to do, like you did the last time. Okay? That's the question I see. Every time you have this problem, you want to do it exactly like. Well, no, there's no asymptote. The asymptote's way over here on the left, right? On -1. Over here, I'm just going to plug in a number, right? So just, yeah, don't overthink it. Don't overthink it. Okay? All right. Okay. All right, next one.
Oh yeah. I was thinking way too early.
You'll find it so eventually.
I was thinking way too early.
Okay, so this one you didn't do. This one's not from the front page. So we're approaching 2 from the left, right? So is it a problem like the one right above, or is it a problem like this over here? If it's like this over here, plug it in, move on. So if I plug in 2, would there be an issue? No, right? There would be no issue. So it's kind of like that one over there, right? In fact, is there an asymptote here?
No.
No, yeah, there is no asymptote. Why not? It has a bottom. Can never equal 0. Can never equal 0. I dare you to give me a number to plug in for x that would give you 0.
Too high. Too high.
There you go, right? And what did we say about, in this class, imaginary numbers we throw out the door. We don't want to deal with imaginary numbers. We don't deal with imaginary numbers. We only deal with what's real. Is there a real number that you can plug in? No, right?
Oh no.
No. Oh, thank you, sir.
Towards you.
There is no number, right? So we plug in 2, and what do you get? So you get 4 over 8. Yep, 1/2. Move on to the next question. Right? So just because it has a little notation up there doesn't mean we need to do all the stuff we did earlier. Okay? All right, so let's see what time we got. Well, this one I didn't, so I'll tell you what. This one, I'm not doing it to be mean, but this one I threw in, I didn't have it last year. And I remember students coming back to it when they saw this one, either on a practice assignment or a quiz review or a test review or the test, and they're like, whoa, we didn't do it. So I wanted to throw it on there. Okay, it's not as bad as you think. Wouldn't you rather see this now than see it on a test, right?
X approaching 90 degrees.
Okay.
I'm trying to draw this circle.
Okay.
I don't want to approach X.
Okay, so.
I don't want to approach 90 degrees.
But it's oscillating, no?
So here we go.
Isn't it oscillating? So it is.
First thing we got to do, we don't know what's going on. Is there a vertical asymptote, and are we dealing with it?
I think so.
I think that's what he told me.
Okay.
That's what he told me.
So let's figure out where cosine is equal to 0. So I was going to give you copies of the unit circle to use like I told you I would, but I ran out of time, so I have to make printers and I'll give them to you. Okay? So we have to figure out where this equals 0. Where does that equal 0? So I'll show you the form I was going to give you. Nope. Let's see.
But pi over 2 is 1. So it's up, so it's 1.
Trying to find mine from last year.
Just plug in dash, so bottom is a 1.
Here we go.
Oh, wow.
Right?
Yeah, just one.
So we're only talking about cosine.
0.
We're only talking about cosine, right?
It is again.
So where does it equal 0?
At pi over 2.
Yeah, pi
90
over
degrees.
2 and 3 pi over 2, right? So that's where there's vertical asymptotes. There's vertical asymptotes at pi over 2, where x equals pi over 2, 3 pi over 2. So vertical asymptotes at x equals pi over 2 and x equals, I skipped a spot, but I'll come back to it in a second, 3 pi over 2. Okay. How do we know those aren't holes? Why did I go right? How do we know it's not a hole at those two numbers?
There's -2's on top.
Yeah, because I can't plug in any of those numbers on top. It makes 0. So they got to be vertical asymptotes. Okay, so were they mean and gave us a limiting value that's one of those? They did, right? They gave us a limiting value that's one of those. So that means we have to draw the picture and we have to go through that stuff. Okay, so it's not that bad. Trust me, it's not that bad.
You keep saying that like it's gonna be bad.
No, not today. Not today. Not today.
today.
Not today.
So it's gonna get bad?
Some days are, nah, it doesn't get bad. But today's not that day, so don't worry about it.
Today's not that day.
Today is not that day. Okay, so we know there's going to be a vertical asymptote at pi over 2, right?
So there's root.
Good. So let's do our thing. Okay. So we know at pi over 2. So we want to pick a couple numbers less than pi over 2, or sorry, only to the right of pi over 2, right? Because it's bigger. So just to the right. Okay, so let's go back to my. So pi over 2. So the next two that are bigger are 2 pi over 3 and 3 pi over 4, right? So let's use those. 2 pi over 3, 3 pi over 4. Actually, you know what? Let's use the ones that have nice answers. So like, yeah, so let's see. 2 pi over 3 is not that bad. That's just -1/2. And then let's use pi after that, because that has -1 as an answer. Let's skip these guys here. So -1/2, so 2 pi over 3 and pi. 2 pi over 3 and pi.
There's 120 and 180.
Okay.
This is 2 pi over 3.
That's 45. It is.
So we're coming from the left, right? So we'll start with pi. So when I plug in pi to the function, I get -2 over cosine of pi. So -2, and then cosine of pi is -1. So that means +2, right? Now let's get closer. 2 pi over 3. So we get -2 over cosine of 2 pi over 3. Bless you. So we get -2 over, was it -1/2?
Yeah.
Yep, -1/2. Okay. So we have -2 divided by -1/2, right? How do we divide fractions? Keep, change, flip, right? So keep -2, multiply, change it to multiplication, and flip -1/2. So when I flip -1/2, what do I get? -2 or -2 over 1, right? So when I multiply those, I get +4. It's rising. So that means it's +infinity.
This is evil.
Okay. That's it.
Yippee.
All righty. So when I say limits to infinity or infinite limits, it means it's one-sided limits that are either going to go up or go down if they are near an asymptote. If they're not near an asymptote, do what you've done before. Okay? All right, so tomorrow we'll do practice. We'll do the next practice. I'll give you the practice to do. And if you have any questions, we got about 5 minutes, so we don't have really a lot of time, but if you have any questions from the homework from yesterday, I'll do them tomorrow. Okay, so bring questions from the last practice assignment tomorrow, and I can answer them in class. Okay, because we're not going to do a new lesson. This lesson went faster than I thought it would.